What if I told you there is a hidden toggle switch inside your own mind? A switch that, when flipped, could fundamentally rewrite your experience of reality. I don't mean just feeling a little more relaxed or focused. I mean a switch that could make the walls of your room dissolve. A switch that could flood your body with a feeling of pure, boundless joy for no reason at all. A switch that would allow you to feel your own body become weightless and float towards the ceiling, and have the experience feel completely, undeniably real. This isn't just feeling or science fiction. This is a real, trainable state of human consciousness. It's the very real, very mysterious, and often misunderstood world of hypnosis. For centuries, we've been fascinated by its power to heal, to reveal, and to alter our perception of reality itself. But how does it work? What is actually happening inside the brain when someone is in a hypnotic trance? For a long time, science has struggled to answer this question, leaving hypnosis in a kind of twilight zone, somewhere between a party trick and a profound mental tool. But what if we could finally flip on the lights? What if we could watch the brain's internal symphony as it plays the music of a hypnotic state? Today on Summary Thought, we are going on an incredible journey deep into the architecture of the human mind. Our guide is a groundbreaking 2023 research paper. An interhemispheric frontoparietal network supports hypnotic states by Maria Niedernhuber and her team. Now, don't worry about the complicated title. We're going to unpack everything in a simple, clear way. This is a story of scientific discovery, and it's a story about you and the amazing potential locked inside your own head. First, we'll explore the great mystery of hypnosis and why it's been so tough for scientists to get a handle on. Then, we'll look at the incredibly clever way these researchers designed their experiment, using master hypnotists to get the clearest look yet at the hypnotized brain. After that, we'll dive into the core findings. What exactly changes in the brain's electrical chatter during hypnosis? We'll talk about specific brainwaves and the communication networks that transform our reality. And later on, we'll explore the mind-bending experiences of the participants. What does it actually feel like to be in a state of deep hypnotic bliss? And finally, we'll connect all the dots and discuss a fascinating puzzle that this research uncovered, a mystery that points to how much we still have to learn about consciousness itself. So find a comfortable spot, open your mind, and get ready for a journey that might just change the way you think about thinking. Part 1. The slippery ghost of hypnosis. Before we dive into what this new study found, let's talk about why we even need it. Hypnosis isn't a new idea. It's been around for ages, but the scientific world has always had a difficult relationship with it. It's not that scientists thought it was fake. The effects are too real to ignore. Hypnosis can be used to dramatically reduce pain, help people overcome deep-seated fears, and even create or erase memories. The problem wasn't if it worked, but how. Trying to study the hypnotized brain was like trying to take a clear photograph of a ghost. The experience is so subjective and internal that it's hard to measure. Early studies gave confusing and often contradictory results. For example, some scientists found that a specific type of slow brainwave, the kind you might have when you're in a deep, meditative daydream, seemed to increase during hypnosis. But other scientists ran similar experiments and found no change at all. There was also a huge debate about where, in the brain, hypnosis was happening. One popular idea was that the frontal lobe, the part of your brain right behind your forehead that acts like the body's CEO, starts to run the show in a different way. It was thought that this boss of the brain could send commands to other brain regions that would override the normal flow of information, telling your brain, for example, "You don't feel any pain," or "This arm is so light it's floating." Another big idea was that hypnosis was mainly a left brain or a right brain activity. Some studies suggested the creative, intuitive right hemisphere took over, while others pointed to the logical, language-based left hemisphere. This confusion meant that there was no single, agreed-upon theory for what was happening. It was a messy puzzle with pieces that didn't seem to fit. This is where Maria Niedernhuber's team came in. They wanted to design an experiment that was so clean and so well-controlled that it could finally start putting those puzzle pieces together in a way that made sense. Part 2. Designing the perfect trap to catch a ghost. To get the best possible look at the hypnotized brain, The researchers knew they couldn't just use any volunteers. They needed people who were true experts, people who could enter a hypnotic state easily, reliably, and deeply. So they recruited 30 master hypnotists, individuals who were highly trained in both guiding others into hypnosis and entering it themselves. These were the Olympic athletes of the hypnotic world, and they were the key to getting clear, strong data. The tool they used was something called high-density EEG. The easiest way to think about it is as a very advanced swimming cap covered in 128 tiny microphones. But instead of listening for sound, these sensors listen to the faint electrical signals that your brain cells produce every second of every day. This electrical chatter forms patterns, or rhythms, which we know as brainwaves. By listening to these brainwaves, scientists can get a real-time picture of what the brain is doing, which parts are active, and how they're communicating with each other. The experiment itself was ingenious. The researchers didn't just look at hypnosis versus no hypnosis. They wanted to know if the depth of the trance made a difference. So, they guided each expert into 2 different hypnotic states. The first was a light hypnotic state called somnambulism, which is a bit like a very focused, guided daydream. Then, the hypnotherapist used special instructions to take them even deeper into something called the estale state. This is an incredibly profound state of hypnosis, a deep, trance-like state of relaxation where people can report feeling completely detached from their bodies. It's so powerful that it has historically been used to perform surgery without any chemical anesthetic. Now, here's the most important part of the setup. For each of these 2 hypnotic states, the researchers had a matching control state. During the control sessions, the participants would listen to a recording that used similar words and had the same timing as the hypnosis instructions, but it was missing the key hypnotic suggestions. It was like listening to a placebo. This was absolutely crucial because it allowed the scientists to know for sure that any differences they saw in the brain weren't just from the act of relaxing with your eyes closed, but from the hypnotic state itself. It allowed them to finally separate the ghost of hypnosis from the background noise. Part 3. The big reveal, a new picture of the hypnotized brain. After all this careful work, what did they find? The results paint the clearest picture yet of what happens in our brains when we enter a state of hypnosis. First, let's talk about those brain waves. The study found a very clear, very strong increase in a specific type of brainwave, the theta wave. Theta waves are the rhythm of the deeply internalized mind. They are slow and powerful, and they are often associated with deep meditation, daydreaming, heightened creativity, and the state just before you fall asleep. The fact that theta waves were so much stronger during hypnosis compared to the placebo condition was a huge deal. It confirmed that hypnosis isn't just about relaxation, it's an active and unique brain state. It's a state of profound internal focus. But the most exciting discoveries came when the researchers looked not just at the activity in one spot, but at how different parts of the brain were talking to each other. They found that hypnosis dramatically changed the communication along a critical brain network. Think of this network as a massive superhighway that connects the front of your brain to the back, and also links up the left and right sides. This highway connects the CEO in your frontal lobes with the parts of your brain further back that are responsible for piecing together your sense of reality and your feeling of being a self located in a body. What the study found was that during hypnosis, the traffic on this superhighway changed. The way the brain's CEO managed and integrated information from the rest of the brain was fundamentally altered. This elegantly brings together those 2 old, competing ideas about hypnosis. It's not just the brain's CEO changing its orders, and it's not just about the left or right brain taking over. Instead, hypnosis seems to be about how the CEO uses both sides of the brain together to build a new kind of experience. The left and right hemispheres start working together in a different way, allowing for a state where your internal, imagined world can feel more real than the external world. To take this a step further, the researchers looked at which parts of the brain were the most important hubs or crossroads in the communication network. Imagine a city's road system. Some intersections are so critical that if they get blocked, the whole city gets snarled up. These are the central hubs. The researchers found that during hypnosis, the importance of any single hub went down. The brain's communication network became less centralized and more distributed. It was less like a city with one massive, critical downtown intersection, and more like a network of smaller towns where information could flow along many different paths. This may be the brain's signature for the feeling of letting go that is so central to hypnosis. Instead of all information being forced through a few critical checkpoints, it flows more freely and fluidly, allowing for unusual connections and experiences to emerge. Part 4. A journey to another reality. What it actually feels like. The brainwave data is fascinating, but it's only half the story. What did the participants, the hypnosis experts, actually experience during this experiment? The questionnaires they filled out after each session open a window into a truly altered state of consciousness, and the differences between the light hypnotic state and the ultra-deep estale state were staggering. When participants went into the deep estale state, their entire sense of reality shifted. They reported having profound spiritual experiences, a feeling of being connected to something larger than themselves, a sense of unity where the boundary between their own body and the room around them seemed to melt away. Their emotional state was also transformed. The paper highlights that participants in this deep state reported feelings of bliss and what they called joy without boundaries. It wasn't just feeling happy, it was an expansive, all-encompassing joy that wasn't tied to any particular cause. But the most dramatic reports were related to the body. In the deep estale state, participants had powerful out-of-body experiences. They reported a strong and convincing sensation of their body levitating or floating. They described a feeling of disembodiment, a sense of being alienated from their own physical form, as if their consciousness was observing their body from a distance. Their sense of time also became deeply distorted, stretching and compressing in unpredictable ways. Their inner world became more vivid than ever, with many reporting the ability to see brilliant, complex colors and imagery even though their eyes were closed in a dark room. These incredible descriptions are so important because they prove that the experiment worked. The participants weren't just getting more and more relaxed. They were genuinely entering a different state of consciousness, a different world with its own rules of perception and emotion. The final question, then, is can we find the signature for that world in the brainwave data? Part 5. The final twist, a beautiful and unsolved mystery. This is where the story takes a fascinating turn, revealing a puzzle that lies at the heart of consciousness research. We've seen that there are clear signals in the brain that distinguish being hypnotized from not being hypnotized. The theta waves and the changes in the brain's communication highway are like a definitive fingerprint of the hypnotic state. We've also seen from the questionnaires that the experience of being in a deep trance is worlds apart from being in a light trance. So, you would naturally assume that the brainwave fingerprint for the deep trance would look very different from the fingerprint for the light trance. But that's not what the scientists found. In a stunning twist, the brainwave data for the light somnambulism state and the ultra-deep estale state looked virtually identical. Think about that for a moment. Even though a person was reporting a simple, dreamy feeling in one state and a profound, out-of-body, blissful experience in another, the EEG measures that the scientists were looking at couldn't tell the difference. As the authors put it, their findings do not substantiate the notion that the neural indices we tested are linked to hypnotic depth. Why would this be? The researchers offer a few tantalizing possibilities. It could be that the listening cap they used, the EEG, is great at picking up the general electrical music of the brain's outer surface, but the changes related to hypnotic depth might be happening deeper inside the brain, in structures that the cap can't hear very well. It's like trying to understand a conversation happening in the basement of a building by listening from the roof. You might hear the overall hum, but you'll miss the details. Future studies using different tools like fMRI, which can see deep into the brain, might be needed to find that signal. It also reminds us that what we can measure isn't always the full story. The richness of human experience, the feeling of joy, the sense of floating, the perception of unity, is incredibly complex. Our scientific tools are getting better and better, but consciousness itself may still hold secrets that we haven't yet learned how to ask the right questions about. This paper doesn't solve the entire mystery of hypnosis, and that's what makes it such great science. It gives us some solid, foundational answers while also revealing an even deeper and more exciting puzzle to be solved. It shows us that by studying the strange and beautiful landscapes of altered states, we learn more not just about hypnosis, but about the vast, uncharted territory of our own minds. We've traveled from the rhythmic hum of brainwaves to the subjective feeling of floating in a sea of boundless joy. The journey shows us that the hypnotic state is not a state of sleep or delusion, but an active, organized, and profound reconfiguration of the brain's inner world. It's a testament to the incredible flexibility and power of our own consciousness. If this exploration into the hidden depths of the mind has sparked your curiosity, and if you want to continue this journey of discovery with us, then show your support by hitting that like button, and be sure to subscribe to Summary Thought and share this video with anyone else who is fascinated by the mysteries of the human experience. Every click helps us unlock and share more knowledge. Until next time, stay curious.